The Secrets of Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit givestarquest.com.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
So today, I'm going to talk about, and I'm very wary of saying this more than 3 times, but it's going to happen. I don't take responsibility for what's going to happen, but I'm going to talk about Betelgeuse. And I refer to the star Betelgeuse, okay? So it's spelled a bit differently, so maybe it's going to be okay. All right, so Betelgeuse is in the Orion Nebula when you look outside. When we see it in the south here, it's like the bottom right-hand star. It's beautiful. It's red. It just looks so happy gleaming there. But there's a lot going on in this star. So it is the 10th brightest star in our sky, but it's probably actually the most restless star, okay?
Restless, yeah.
It is beautiful to observe with the naked eye and with a telescope. Me and my son enjoy pointing out Betelgeuse every night when it's not cloudy. And I did manage to take a photo with my telescope, but you zoom in on it and it's like just bigger than what you'd see with your eyes. So it's nothing too special, but it is definitely red and it's beautiful. Betelgeuse is actually a red supergiant, and it's, if we're going to get specific, it's classed as a spectral type M1, M2 star. Now, what's amazing about Betelgeuse is actually in the final stages of its stellar evolution. So it's actually used up all its hydrogen fuel in its core, and now it's fusing heavier elements. In other words, it is on its way out. It's dying. Okay, so it's also called a variable star, which it means its brightness fluctuates. Now, if you've been watching Betelgeuse, you know that a while ago it was actually really, really bright and dark red, but it did go through a bit of a dimming phase around 2019, 2020, and I do remember seeing that myself. And scientists thought, oh, maybe it's going to blow. But, when it does blow, because it's going to go, right? It's going to have a supernova ending. So it's going to go, it can go any time. So they're saying any time from tomorrow to about 100,000 years from now. So we don't know.
They always say that. Yeah, I know. Yeah.
The thing is going to supernova, and apparently we will see it pretty well in our sky. All right. Now, to understand the scale of Betelgeuse, its size, if it replaced our sun, so if Betelgeuse was our sun, the surface would extend past the orbit of Mars and probably reach all the way to Jupiter. So it's about
goodness me.
7. Yes, that's how it's, and it's nice and fluffy. So it's like got a lot of gas and dust on its outside, right? So it's probably about 700 to 1,200 times the size of the sun, and roughly about 7,500 to 1,400 times brighter. So this guy it's a bright thing. It's a huge bright thing and beautiful. Now, astronomers know that it has pulses. So it's pulses. It's got a 400-day cycle, and that is the star physically expanding and contracting. But there is a second longer pulse, about 2,100 days, so maybe every 6 years. But today we're looking at a brand new paper from January 2026, led by Andrea Dupre from the Harvard Smithsonian Center for Astrophysics. Now, their team has found evidence for a theory that was once considered like crazy, but they're now saying that Betelgeuse is not alone. It's not by itself. It actually has a smaller companion star that orbits it, and they've named it Siwaha. And it's actually orbiting inside the giant outer layers. So to understand, we've got to look at Betelgeuse's chromosphere. So that's the massive glowing mist of plasma that surrounds the star. And this extends to about 270 milliseconds, or roughly 6.4 times the star's own radius. So it's big. Now, the data shows that Siwaha, which is like a pre-main sequence star, or it's a star that's not fully born, it orbits at a distance of only 2.3 times the star's radius, so it's quite close. It also means the star is submerged. It's like plowing through the thick, hot gas of Betelgeuse's atmosphere. And this is where stuff gets interesting, right? So the companion is moving at 43 kilometers per second, while the speed of sound in the gas is only about 6 kilometers per second. So we would say it's moving at like Mach 7. So just like
Mach 7? Goodness me.
Like a supersonic jet creates a sonic boom. Yes, Siwaha creates a massive shockwave and a dense trailing, it's called a wake behind it in the gas and everything else. So now we can't see Siwaha directly because Betelgeuse is just way too bright. So, and the companion star is about 6 magnitudes fainter. So what the researchers did was they used spectroscopy. So we know that spectroscopy is like the study of light broken down into its component colors. And this was to find the shadow of its wake in the atmosphere of Betelgeuse. So they used the Hubble Space Telescope and some ground-based observatories. They monitored specific elements like manganese and iron and silicon, and they noticed that after the companion star passes in front of Betelgeuse, or they call it a transit, these chemical markers change significantly. So you can imagine it's like a boat moving across a lake. So if you stand on the shore, you'll see the boat pass first, and a few seconds later, you'll see the wake. So the researchers say you are seeing exactly that. The companion star passes, and then a massive wake of dense shocked gas follows it, and it blocks out a certain wavelength of light. So they call it circumstellar absorption, and it reaches its peak around the time when the companion star moves to the far side of the star. So this wake is not just a tidy line, it's an expanding cloud. And the paper explains that the wake spreads out sideways at the speed of sound, which takes about 3 years, exactly half the orbital period, to grow large enough to cover the face of the giant star. So, you can see why it would dim. So this helps explain the 2,100-day pulse. When the companion is on the far side of the orbit, its wake has expanded so much that it acts like a thick curtain, contributing to the star's dimming. So now we know why it dims, right? So more importantly, this solves the fast rotator mystery. So Betelgeuse actually spins faster than a star of its age should. And it believes that Siwaha acts like a kind of a swizzle stick that stirs the atmosphere and transfers angular momentum to the giant. And the stirring also helps fling gas out into space at 20 kilometers per second, explaining how Betelgeuse sheds so much mass as it nears its supernova explosion. Now, so this discovery does change the way we look at supergiants. Okay, it's not something that we've found before. It suggests that maybe many giants may actually be in a binary system where they have a smaller star hidden in its gas. So currently, Siwaha is tucked behind Betelgeuse from the way we're seeing it, so from our perspective. But researchers say that there is a date for its return, and it should be around August 2027. So next time you're looking at Betelgeuse, you can look at it differently, right? So you can look at it as a high-speed supersonic chase occurring deep inside a star.
Yeah.
So, it's so cool. I had to share that one because I've been looking at Betelgeuse for a long time now, just observing it nearly every night. And I know that I did notice the dimming, and I was wondering what was happening. And I did read that, it's going to supernova any minute. But no, it's actually because it's got a little star flinging dust out and covering it up. So, so how's that? Isn't that amazing? I thought it was amazing anyway.
So, wait, so Betelgeuse is not going to supernova, is that right? Or it still is?
Betelgeuse is going to supernova, yes. But it's got this little star going around, and it's picking up all this dust around it. Yeah.
So last year, Lino, I, and Don, we talked about T Coronae Borealis, which is another star which is going to nova as well, right? This one, so I'll explain it in 2 seconds. You tell me the similarities and differences just to help me, because this is really cool, right? So Coronae Borealis, it novas every 80 years, right? So it doesn't explode and it's dead, right? So it's absorbing gas from another companion star that it has inside its atmosphere, but like, and so
next to, right?
Next to, yeah. So every 80 years, when it has taken enough gas, I'm not very scientific, so the way I'm saying it, it will nova and it becomes a brighter star in the night sky. It just looks a bit brighter than it was before. So Betelgeuse, its nova, is it the end of Betelgeuse, or is it a similar kind of situation?
Yes.
Or
no, so it's not drawing anything from the little star, but, well, not that they're mentioning, it's not the same situation as it's eating the other star. Like, because I have seen documentaries about that. So like you can get two stars, one's eating the other one, and that would explain the one you're talking about. But Betelgeuse is on the way out. So eventually, when everything is exhausted, it is just going to explode. It's going to cause a massive explosion.
I know what that feels like, by the way, when you get exhausted and you just explode. I know exactly how that feels. So, yep.
And then they say what will happen to Betelgeuse once it has exploded. It will supernova, and then it will either leave behind a neutron star or it will turn to a black hole. So, it's never the end. There's always something else, It's pretty cool. Yeah.
So interesting. Yeah, 2027, because so T Coronae Borealis was meant to be 2025. Now it's 2026. They said it could be 2027, so we might have this year of exploding stars next year.
Wouldn't it be amazing if we just have a bunch of them in the sky and we could see that?
Yeah. Even though they all exploded, millions of years ago, really.
Oh, well, exactly. So you're right about that. What we're seeing is like when the light eventually reaches us. But that's so true. Yeah.
I still get my head over that. Yeah. No, Lindsay, I'll just get when you look at, like Caroline told me, looking at a star, it's not at the time, it's how many light years and how many things. Like, okay, I'm looking at something way in the past. Is that correct?
Yeah. Yes, even our sun is 8 minutes ago. So what we're seeing
is
cool,
Sorry, just for those, because people can't see, Lino just looked over his shoulder out the window to see, look at the sun. That was 8 minutes ago, yeah.
8 minutes ago. It's so cool.
Yeah.
Oh, wow.
So as another mind-blowing thing, so that means like really Betelgeuse isn't there anymore already. It's already gone.
It could. It could be.
There's a black hole there.
Yeah, it's just a black hole
right now, but we just, it's really fascinating. Good one, Caroline. Thanks for sharing that. Yeah, that's good. Astronomy is always mind-blowing to think about. Yeah, all the...
it's the best.
The 1% of knowledge we have about space and how much more there is to discover.
And my son and I, like Harry, he's 11 and he's just like discovered that he loves space. So we're watching space documentaries all the time and it's just great. I'm learning new stuff all the time. It's so fun.
We should set up a thing in the future where we ask listeners who have telescopes, just like you've got, to share some of their photos. Yeah, we should do something like that. Yeah.
That would be great.
We'll talk about it.
In fact, if you like, I can share my Betelgeuse photo. It's not the best, but you get an idea of what it looks like.
Yeah. We'll find some ways to share. Like Discord and whatever. Yep. Awesome.
Yep.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, The Secrets of Stargate. Find it wherever fine podcasts are found or at sqpn.com/Stargate.